Hello friends, let's continue our journey. We did some videos on the fundamentals, then we did couple of videos on the use cases, and then one with practical and theory on how to do the bias testing and evaluation of the agentic workflow solutions or the voice agents. So let's now do a understanding on how to deploy the agentic workflow solutions. Suppose you make a solution and your current need is to cater the 1 million users, and then slowly when your application gets popular, something like Aratai, which overnight got popular and then needs to suddenly scale from 1 million users to 10 million or probably 1 billion users, how step by step you should do the deployment in cloud, whether it's Azure or AWS. So what are the steps we need to take care? The business logic does not change, but the infrastructure and the way of deployment changes. Since all my experience of cloud has been on AWS and my AI experience is AI Azure Foundry, I am limiting it to these two cloud technologies, but there could be multiple solutions and there are many more other platforms to build AI solutions, right? So, the scaling roadmap is what are the critical components we need to understand, and vector database is the one of the important component to it. Like so, in case of RDBMS data with vector extensions, we use tool database like Postgres, which allows having vector embeddings within the RDBMS information, or Pinecone kind of database, which can be globally installed with and can be sharded and have read replicas to read the data from different locations. The critical components are like large language models, which also needs to be have available as the more the number of users increases. So it should be able to connect, and agent should be able to get the response from the language models, right? So one of the things, since I worked in electrical engineer and I thought about it when this question was asked at different forums, or when you want to build, so just understand, think, when you in your house there is so many electrical appliances connections, so that is all the connected load, but in actual we don't use all the load, but some very minimal load, and that too in the daytime. We don't need, we use different apparatus, so we need it, and in the night time again our actual load decreases, right? So same concept is there, which industry leaders or people get worried how our AI application will cater to suppose one state population, and there is a gas energy company which services, and there are suppose 8 crore or 80 million users. So do 80 million users at the same time send the request? Not really. Hardly 3 to 5% people will actively use the solution from the registered users, right? Even Amazon, if there is some everyday people will buy, all the users will not buy, and so whenever there is some promotion so that time on 2-3 days there will be peak load, and that load will be also not 100%. So in this different kinds of number of users, how to make the optimized deployment and cost effective, right? So like there are different services, like in AWS we have step functions. In AWS we have in Azure we have durable functions, or if we go beyond that, we have we can use Kubernetes services, or ECS in Elastic Container Services, and so on, right? So to use Kubernetes services, you should understand some basic concepts. What are pods, what are containers, what are images, and how they are deployed. So like when we build any solution on a Windows machine, or any operating system, we build a exe, but that exe that solution cannot run on its own, so it needs some additional libraries to add to it, right? So all those libraries combine everything, put into single unit. It is called the image. When that image is instantiated, it is called a container. When there are multiple containers in a single pod instance, so pod has can have multiple containers, and those pods are dynamically created in a cloud behind the load balancers. So as and when required, the multiple instances of the pod can be created, and those pods will have the IP address, and all the containers within that pod will be the using the local host. Okay, so up to 1 million users, if you are building any application using Amazon Bedrock or Azure AI Foundry, those platforms are capable of handling solutions and multiple users in parallel. So we as a application creators, architects, don't have to worry about it. We just have to make sure we build the application, test it, and it's working, right? So if we are using 1 million users, so even if you take 1 million users as 5% concurrent users, so 1 million into 20 means up to 20 million users we are able to handle with basic platform capabilities, right? So for growing from 1 million to 1 billion users, we need explicit orchestration, and then we need to have a segregate the agents and the business logic which we build. So like in if you use Bedrock, you use Boto 3 library, you create agents in the Bedrock, and those agents call the Lambda functions to do the execution. While in Azure AI Foundry, we use LangChain and LangGraph objects, where nodes and edges for workflow solutions are called as defined in the LangGraph, right? So above 1 billion users for hyperscale, how we should globally deploy the solutions, like we use different regions globally where to install the solutions, and do the replicas of database, read replicas, and they are sharded, and we have multiple instances, and there would be functionalities available in cloud where it will whenever the user request comes, it will redirect to the nearest instance, so that there is a low latency, right? So let's go and understand the in deep the physics of concurrency. So it's not based on how many users have registered, but it's based on how many users are actually using the solution in parallel, right? So there might be a huge number of registered users, but in actually it all depends on the session states, database connections, network sockets, compute threads, memory allocation blocks, and so on. So like active concurrency is typically 5 to 20%. In regular time it would be 5%. In peak loads it will reach up to 20%, right? So how the auto scaling logic is can be applicable to the database, to the large language models used, and the agents. So there are different criteria which is considered for auto scaling, right? So how many request per second is received by the solution, right? So based on that, accordingly the auto scaling is done, right? So suppose a solution is based on the current customer base. You understand that okay, 1,000 requests should be received. So you start the moment you start getting or near to 1,000 requests, you start creating more instances, and then it should be able to handle the request from the user and do the processing and give the response. The other thing is how many users have sent the request and they are waiting to get the response, so that latency number of requests in queue can be counted, and based on that the new instance of the pods or the containers can be created, right? Or based on what kind of solution scaling solution we are using. The third thing is the CPU usage. Like if there is within a container which is access or the pod which is catering to the user needs, and the CPU usage has gone beyond 80%, means so it should if it suddenly increases, it will bring down the system. So it would immediately start creating more instances of the solution, and load balancer will accordingly divert the request to those instances. The fourth thing is the network input output. So like agentic solution needs to connect to the database, vector database, or the make a tool API call to, and then how many those requests are getting called, and is there is a more connections required. Accordingly you should have more replicas of the database, or the sharding has to be done, so that request can be handled by the system. And at the same time we should be able to take care of how many agents are trying to reach out to the large language models connections, and accordingly we should have that many connections available, right? So let's understand, if we are using a basic less than 1 million user kind of implementation, so how it will be in AWS and Azure. So in AWS, when a user sends the request, it goes to the API gateway, and that API gateway sends the request to the Bedrock agent, and the Bedrock agent will create the instances of Lambda. So so if it's a cold Lambda creation, it will take time and there will be latency. So some set of Lambdas you should have a hot creation, so they are active, and the moment request starts coming and it reaches the near threshold, it should before those are utilized, more Lambda, active Lambda should get instance should get created. So like API gateway will have the load balancer, and it will divide the requests. Similarly, in case of Azure, there would be managed REST endpoint, and that managed REST endpoint will send the request to Azure AI Foundry, and AI Foundry will will have some container instances active, and the moment it reaches the threshold, it will create the more containers. So in case of Azure AI, OpenAI lightweight LangChain and LangGraph libraries are used, while in case of Amazon we use the Boto library. So suppose now if your solutions number of users are increasing and now you need to cater more than 1 million users, so how the solutions can be redesigned. And so this very same agents in case of AWS, we can create the stateful workflows for which we can use step functions within which we have state machines. So in step functions, similar to you have nodes and edges in OpenAI LangGraph, similarly such steps and the workflows can be defined in step functions, where it can go in a single linear fashion, and wherever you need to run in parallel and then club the response together. So such flows can be defined in the form of JSON objects, and with the help of AI you can create agent and which can dynamically which can create such objects for you and make your work implementation easier. And I have mentioned that in the one of the use case of of the AI, right? So the in same thing, if you want to do in Azure, how you will do, you can use Azure Kubernetes services or Azure container, right? So let's go into the details. So what is a so, and as I mentioned, like pods will have containers, and so what is a container? So container will have so like if you in Azure you implement it and that you create a container of it. So entire agentic solution will have multiple agents. It will start, it will have orchestrator, guardrail, then the orchestrator agents, then the based on the workflow you will have multiple agents reaching out to knowledge base or SERP API, making tool call, and then at the end it would be having synthesizers, and then guardrails to validate, and also at the same time it would be having agents to do the bias and test evaluations, right? So that entire container works independently, and internally it will have localhost, it will have its own memory and CPU limits, and then it can connect to the external cache and get the information, right? So how the flow happens? So you make a API call, it triggers the container. So the container then starts processing that input. It will instantiate the graph object. That graph object will execute all the logic, and the container we internally can call LLMs, knowledge base using the API, and get the information and then send the response. So this implementation can also be done in a different way. So like the user, instead of waiting for the response, it can be done using a WebSocket, so that the information user don't have to wait in listening mode. Once the response is generated, it is sent to the user, right? So if you want to scale your application beyond 1 billion users running at using it at the same time, probably it will be the solution which is good enough to cater the entire human population worldwide as right? So in such solutions, when the what can be done is a WebSocket is created, user sends the request and does not wait for to get the response. So the request goes API puts the request into the queue and the bus. So from there, the agentic different agents will first will pick the input, and then there could be different queues can be used. Like in AWS, we have SQS where point-to-point service, or each agent does the processing and puts the its response back into the bus. It updates the data into database like DynamoDB on AWS or Cosmos DB on Azure, and then the next agent can pick that information and process it. So suppose if we are using some queue like Kafka, it will have the broadcast agents which will once processing it done, it will broadcast it, and then there will be receiver agents which will be looking for particular kind of data on the bus, and which is related to it, and it will redirect it to right agent to process it, right? And finally the after all the processing, the response is sent to the user, or user can do the there is a other solution where it can keep doing the polling, and that polling can be exponentially increased so that all the users does not hit the server at the same time. So suppose if polling is done every 2 seconds, so next time if doesn't get the response, it increases to 4, 8, 16 and so on, right? So for hyperscale, if you want to globally install the solution, so there would be multiple instances, and when the user sends the request, it will the global accelerators will route it to the nearest instance, and all the replicas are active, so that request reaches the nearest instance. So like in big data technology, you have or other technologies also active passive kinds of nodes, where if one nodes goes down, then the another master nodes becomes active and takes the control. But in this kind of solution, all instances are active, and the load balancers can redirect the request to the nearest instance, right? So now next thing is important is what kind of database we are using and how we can scale it based on the size. So like Postgres is used where it is a RDBMS data, and it will have a vector extension for the vector embeddings, right? So there's a consistency, availability, and partitioning. CAP theorem is based on which we decide what kind of solution or database is we can use. Like if you need consistency and availability, probably you need to give up with partitioning. If you need availability and partitioning, probably you need to give up consistency. Consistency, like suppose you update data, and in other replicas same data need to be updated, which may take some time to update it. So Postgres is not suitable where you have partitioning, replicas, or consistency is important. So in such case, we can use Pinecone database, which is specially designed for vector database, or there are graph database like Neo4j. So in Pinecone, it can be scattered to global data, it can be sharded and partitioned, and then vector database, vector embeddings can be any question asked, the vector embedding can be sent to the vector database, and it can find the embeddings into the knowledge base and return in the response to the agent. So like in if we for beyond 1 million and 1 billion users, if we want to use container services, so if you in there's a enterprise Kubernetes services or Azure Kubernetes services available in both Amazon and Azure. While in Amazon they have their own solution similar to Kubernetes, which is called as AWS Elastic Container Services. So like I mentioned earlier, there is a concept of pod, and within pod we can run multiple containers. So in Kubernetes we use sidecar containers, which will do the other jobs like TLS, MTLS connections, logging, and all the jobs which will support the main agents. So main agents can continue their assigned task, and sidecar will take care of the support. So similar thing is done in a ECS, which is done by in the form of task definition. The advantage of that is other AWS services are easily accessible and configurable in the policies and permissions to be accessed by the containers. And so those they are tightly coupled. Okay. So the way of scaling happens based on some external factors and the internal factors. So like external factors are how many requests are coming in the queue. So Kubernetes event driven logic is used in the scaling, which depends. So every request coming is an event. So how many requests are coming, and is it nearing the threshold? Accordingly, it will take care of creating more pods for access, handling the request. While CPU usage and those kind of things which are internal to the pods, that is when those thresholds reach, that also metrics are used to create the more instances and replicas of the pods, and so that load balancers can divert requests to those new pods and balance the user request and get the faster response. At the same time, we need to make sure there are enough read replicas of the database, and there is a pool of LLM to which agents can send the request, and otherwise database and LLMs will language models will become the blockers to the agents. So software level, infrastructure level, and the supporting database language models used at all the different levels, the scaling should be seamless and automated. Right, so let's understand and do in a summary. For less than 1 million users, compute is serverless, managed agents, and the orchestration is implicit. So Bedrock and AI Foundry are capable of taking care with single data instance. We are able to handle it. So less than 1 million users means 20 times of that size of population. You are able user base. You are able to provide the solution. If if you are want to handle more than 1 million users, means uh, 20 times that kind of user base in your registration base. You need to use the containers and orchestrators. So here we use Kubernetes service or Elastic Computer service, computing services, and the orchestration is explicit. So you can use step functions in AWS or and self-hosted, right? In case of data, you need to have more read replicas, and so the request can reach to those uh, replicas, and the database queries response is shared with them. And with this, your usage of cache is important, because in cache we can look if the same question was asked recently, and the response can be used. If we are scaling beyond 1 billion users, then we need to use global distribution. We need to have uh, instances in different regions, distribution of regions, and then we need global accelerators which can divert the request to the nearest instance, so that global mapping should be maintained within the cloud. Uh, and in such case, orchestration is asynchronous. So we have data put on the bus, and the agent will pick the data from the uh, request from the queue and process it, and if required, multiple instances of those uh, agents can be created. So suppose like the job of first agent is just to read the input and then check if that input is in the cache. It is not doing much of processing, so its output will be fast, so that agent instances can be less, while the agent which is actually scoring the questions, dividing those questions into subtasks, that agent will take time, and it may become a blocker. So there's more instances of such agents can be created, and the database can be uh, in such solutions, database need to be sharded and have global tables. Even the data, transactional data or data based on the user for that country can be kept, or the region can be kept locally until that person moves to the another location. So let's now go through the quiz, and I will read all the questions and show you the options and the hint. You can pause it and see how much you have gained the knowledge. When provisioning infrastructure for a RAG based application, which metric is considered the primary driver for scaling decisions? Here are the options, and here is the hint. Next question. For AWS based generative AI workflow serving fewer than a million users, which architectural component is recommended for internal routing and orchestration? Here are the options, and here is the hint. How does AWS step functions improve the workflow for large scale applications more than a million users compared to using Bedrock alone? Here are the options, and here is the hint. Next question. In hyperscale architecture more than a billion users, why is Amazon SQS recommended for the ingestion workflow? Here are the options, and here is the hint. What is a key networking characteristic of a Kubernetes pod in services like EKS or AKS? So here are the options, and here is the hint. When deploying a LangGraph application to Azure AI Foundry, what is the recommended approach for scaling the individual nodes of the graph? Here are the options, and here is the hint. Okay. Next question. Which AWS service is specifically mentioned as a way to handle internal service discovery for the ECS task? Here are the options, and here is the hint. Next question. Which configuration is suggested for AWS Lambda functions to minimize latency issues during high scale usage? So here are the options, and here is the hint. Next question. According to the general benchmarks for applications, what percentage of daily active users typically represent the average concurrent usage during peak hours? Here are the options. And here is the hint. The last question. In the context of Azure AI Foundry, where does the actual execution of the LangGraph node logic occur? Here are the options, and here is the hint. In next session, we will continue more on deployment, and then we'll start back with the fundamentals on context management and other topics.